wanted to
Cool.
do today was just quickly introduce you to something that is number one, declare your biases. This is my day job. I work for CrateDB, which is an open source database. I created a MicroPython driver for CrateDB, which turned out to be quite easy to do because one of the ways you can interact with the database is through an HTTP endpoint. So you can post SQL statements into the database and it will put things in tables, and then you can go away and do things with them, or you can equally retrieve things. Is this a bad architecture idea from a IoT perspective? You know, should a little device know about databases directly and table structures and all of that stuff? No, it probably shouldn't. You should probably use MQTT or something else. However, it's interesting listening to Damien saying, you know, sometimes you have to use MicroPython when you develop MicroPython to see what the developer experience is like. I work in developer advocacy. This is largely about teaching people how the database works through the sort of essentially gateway drug of small devices. So, you know, you can do a workshop where you can teach people SQL statements in a console. It's very boring. Or you can build something where that is going to annoy me because it's the screen won't keep it in focus. But you can build something where people get to play with the device and actually do some things. So the way this works is, let's say it's got an HTTP endpoint on the database. The database is open source. You can run it in Docker or the cloud. And what I've got here is a little demo that's running on the Pico Enviro from Pimoroni. We can look at some code for that. The database bit is essentially just as easy as telling it a host name, username, and password. Connect to the Wi-Fi, grab some data. So we've got a lot of code here that's just Pimoroni demo code for pulling things from their sensors that are built into this device. And the interesting database bit is basically down here. We're just going to say, hey, run a SQL statement and insert some things. Again, should devices in a production environment know this level of information about the database? No, not really. If you're building hobbyist stuff and you're using a free tier open source cloud thing, then sure, go for it. It's a lot of fun to do things this way. So every so many seconds, this thing is going ahead and putting things into a database. I have the database over here. We can run a query against it, and you can see things look a little bit hot in my office here, probably because of the massive live streaming lights that are on, and that's also why we've got quite a lot of light. But we've got a table here that has been been created, and stuff is going into it. When I built this table, I built it using a feature of CrateDB that is kind of handy for IoT things, which is schemas change over time. So we said this is a dynamic column table. So I can add columns to it dynamically. I can just put columns that don't exist into an insert statement. The database will create them. And I also had it go ahead and do some sort of basic aggregation. So every time I put something in there, we truncate a timestamp and create a month column. So we might want to eventually do averages over months for this data or something like that. So right now I've got just these few things going in there. The device itself actually supports a few other things. So up here, I've been capturing pressure and gas in a dictionary that I've called others. And what if I wanted to send that to the database? Well, I don't need to do a schema change or anything like you would with a lot of other relational type databases. I can just basically put others into this statement, put another placeholder for it. And then hopefully when we stop that and rerun it, then what we might see is, here we go. So my new record, the schema has now been extended. I've got this new column called others that was actually created from the Pico pushing something into the database. And inside there, we've got gas and pressure values. And if you're storing even more random documents, you've got data that's got more structure to it, then let's just, Again, this is a terrible idea. You wouldn't store metadata like this in every individual record in the database. You put it in another table and do a join. But we should be able to save that to the device and run it. Oops. And what have I broken here? Oh yeah, I need a comma after gas. There we go. If I run this, what you'll see is it reconnects and starts sending things. And then what we should see is my newer records have an object that has a sub-object in here. And we could just keep creating things. So if you've got standard format JSON documents or whatever, you can use that. So the long and the short of it is CrateDB is an open source database. There's a free trial in the cloud. We built a MicroPython driver for it, partly as an educational tool, but it's also interesting to play around with for hobby projects. And if you wanted to build like a citizen science project with some sort of I went to Raspberry Pi last night and somebody was monitoring rivers and someone else was monitoring blood pressure. And if you wanted a database that's free in the cloud for basically forever, as long as you keep using it, and you wanted something that talks Postgres and you can build a Grafana or other data dashboard on top of, then this is a good idea for that. Implementation wise, my user experience is first time building something, a library for MicroPython, was pretty straightforward. It just uses the request library to send an HTTP request in a format the database respects, and then does some really light processing over the result. So dealing with things like error codes and exceptions. And then the way that our HTTP endpoint handles authentication, you need base 64. So when I built this, I had to figure out a little bit. Oops, where am I going? I had to figure out a little bit how to package something for MicroPython for distribution, so that when you install it, it installs my script, the CrateDB driver, and also a standard library requirement. So it needs the base 64 library that isn't part of MicroPython by default. So this was fairly simple to work out. And once I got that, you have what you'd expect from MicroPython, which is a fairly nice install process. To get this installed on your device, you can either write a little program at the REPL, or you can install it with MP Remote like you might expect. So that was really all I got as a very short version of this this talk. But essentially, if you're interested in trying this out, it's all free and open source. Please go do it. I've tried it out extensively on the Pico W and not very much else. And I'm hoping to build some other projects that use it as some sort of interesting data source or visualization source in the future. So yeah, that was me.